welcome. This is analog oscilloscope. Today later analog. Almost we have display area. This is x-axis plot where this is y-axis plot. The value will be indicated on this one. This is a zero reference. This oscilloscope has almost focus area switch. This is a probe input, which is for channel 1, where this is used for channel 2. So from channel 1 side, we have this component, where this is almost channel 2 component is almost this is used as a ground, as a common. So for channel 1, let us see this one. Here is a probe where you have to use for connecting to the load. This is a selection for source, AC source, DC and the ground. Almost for our case, we wanted to check AC supply. So let us make that. This is lines, vertical lines means the values will be indicated on this one. Most of the time that is voltage values. So the voltage magnitudes will be displayed by using these inputs. So we have two setting point here. It is the smallest one. This setting must be almost adjusted on this one. So this is voltage, millivolts, and the volts. So from the lower value to the maximum one, we have some certain values. By using this adjustment, you can adjust any values on this one. This setting will be called voltage per division. Volt per division, which assigns the value of this y-axis. Here is a position. You have to adjust the outputs by using this position. And this is the value used for with your probes. You can adjust from here, so that is indicated that values. It is also the x-axis and the y-axis position will be adjusted by using this one. You can adjust the value of the signals, which is plotted on this one, by using that one. Where this one is the horizontal lines values. The horizontal value will be indicated by that plot, which is using time per division. So this x-axis is indicates x-axis values. That means time per division. The signals will be determined in terms of time intervals you have set it. So you can set from this one: second, microsecond, millisecond, microsecond, and so on. So you can choose any values from this one. This is about channel 1. For channel 2 also you have the same. So for channel, you can select, if I wanted to use this channel 1, I have to make this one on channel 1, and the output will be almost, I want it to be auto. This is trigger. So by using this one, I can use this oscilloscope. First, we have to calibrate oscilloscope. The oscilloscope, if I use this 10 times 10x, I have to adjust this one also on 10 times x. If we leave this one, almost we can make on times 1x. So that is the value we wanted to accurate the values of the signals. Here for channel 1, we can use, first you have to test what about this output of to the load. That means most of the time you have, if it is a ground, for ground testing also you can use like this one and get some output. By the way, this oscilloscope is for a time being, it is unfunctional. For teaching and training purpose, you can get some information from this one. So we have two types of oscilloscope: analog oscilloscope and a digital oscilloscope. This is a best analog oscilloscope. Most of the time it is easy to learn. From this digital oscilloscope, we have almost power switch, and the other one is for the purpose of adjusting frequency, signal, wave output, and others necessary informations that is simplified by this one. Also, we have channel 1 and 2. Here is a channel 1, where this one is channel 2. So these are common for this one, voltage per division. That means when you matter about vertical lines. And also you have voltage per division for the channel 2. This is for the channel 2. So you have to select this channel, whether channel 1 or channel 2. Here is a time per division or second per division. To say that it is time per division, which indicates the x-axis, where voltage per division indicates the value indicated on y-axis. Others are almost cursors, or what you have to use for adjusting the levels of the signals and also increase the intensity or the light of that. Here is how to leveling that almost output or signals by using that. So the calibration method for digital is also the same with analog. So you can first give some ground for this one. Almost you can check this one. Most of the time this reads 1 kilohertz frequency, so our probe must be matched with these values. Here, after that, you can adjust and see your output by adjusting by using these additional components. So you will get that during powering this digital oscilloscope. Then we are going to see how to calibrate and adjust this digital oscilloscope on our third videos. Thank you.